In this lab exercise, we'll show you how you can solve quadratic equations using the relevant methods from the math class. And before you actually start going through the tutorial solution, I would suggest you try to solve the problem yourself and read through the description of the problem, especially how you can calculate this formula here using the methods from the math class. And also, when you're trying to solve the problem, also get yourself familiar with the API page for the math class. If you click on the link over here, you'll see that for the class math, there's an API page in the Java documentation site. And over there, you can see that every method over there, you can see this section called method summary. Every method has the following signature. So the signature of the method contains several parts. The first part is the name of the method, and in this case, that's ABS, standing for absolute value. And the second part is the input parameters, which can be 0, 1, or more parameters. In this case, the absolute method takes just one parameter, A, of type double, and it is going to return. So the third part of the signature is a return type. In this case, it's just double, which means the absolute value method is going to take one double number and returns to you a double number. For example, if you say math.abs and then you give minus 2.25, it's going to return back to you positive 2.25. You can see there's also a short description about what the method does. You can also browse through for other functions. So basically, all the mathematical functions that you learn from your high school math textbook are available here. Okay, that's that's something I'll leave up to you to actually explore the page and get yourself familiar, and you can solve your own problem using the methods here. And one thing to note, you can see that every method in the math class is actually static. Static, for now, you can all you have to know is if a method is actually static, that means you can call the method directly on the class. You can say math dot, for example, math.abs and math.power or math.square root, etc. Okay, so I'll leave this page reading up to you. But for this lab exercise, we only need the power method and also the square root method. Okay, let me just go back to the problem statement here. So that's something you should really read by yourself. And this is the expected output, which you should also read, get yourself familiar before you try to solve the problem yourself. And you should really try to solve the problem before you go through a solution. Otherwise, you wouldn't learn too much. Okay, let's now go over the solution of this exercise here. If you launch your Eclipse, and then let's create a project for today's exercise. So new Java projects, let's say CSE114, Spring 16, and Week07, and Lab exercise 2. And inside, we're going to create a method over there, a class, and let's call that let's see your instruction here, solve quadratic equations. Okay, and finish. According to the instruction over there, so it says that your program should repeatedly prompt the user for A, B, and C of a quadratic function and solve the roots if possible. Okay, so basically you can see individual step for this program here will be to prompt the user for A, B, and C, and then solve the equation. And we're going to somehow to write this code first as a single action, and then we can see how we can repeat this action as long as the user wants to continue. Okay, and then so we can wrap this fragment of code inside the body of some while loop. So we'll do the single step first, and then we do the repetition later. So for single step, we actually first of all let's first declare a scanner because we're going to read integer from the user. Okay, so now we're assuming that A, B, and C are constant, integer constants. So scanner input assigned to new scanner system.in. Okay, so now we will first prompt the user for an integer constant a. Oh, okay, so we'll say system.out.println. Okay, we can say enter an integer constant a. And now, because we're actually going to, later on, we're going to ask the user if they want to continue to actually enter another set of A, B, and C. So we are going to have a mix of integer and string reading. So that's why following each integer, following each next int, we have to have a next line, as we said before. So we're going to say integer A is assigned to input.nextInt. And following that, we're going to have input.nextLine, just to consume the new line character. Okay, that's A. And according to instruction, if you find out A is actually negative, if A is actually 0, and that means the denominator of the fraction over there is actually undefined. In that case, we have to report an error right away without going further to prompt the user for B and C. So now we have to do a case distinction right away. You'll say if A happens to be 0, in that case, it is simply not a quadratic function. Okay. Otherwise, that means A is not equal to 0. Okay. Implicitly, A is not equal to 0. Or alternatively, you can say not the case that A is equal to 0. So both expressions are equivalents. Okay. When A is equal to 0, and we're going to say system.out.println, and then error, the equation is not quadratic. Okay, simply means we cannot solve it because the denominator of the formula is actually 0. Otherwise, we can now prompt for B and C. So we say system.out.println. Okay, and then we'll say enter an integer constant b. Okay, and then the integer b is assigned to input.nextInt. And similarly, we're going to say input.nextLine over here. And then after prompting for b, we're going to prompt for c as well. Okay, let me just do some copy here. So enter integer constant c, and then we say c is assigned to this. And now after we have got a, which is not 0, and b and c, so now we have to do the calculation of the discriminants to see whether that's larger than 0, equal to 0, or less than 0. So now we can calculate discriminants. In this case, we're actually going to do the b squared minus 4ac. So you can say integer discriminant is assigned to. So now when you say b squared, you can simply say b times b. But I'm just going to show you how you can use the math method. You can say math the power. So b to the power of 2. Okay, b squared minus 4 times a times c. Okay, and one thing to note, the power function in the math class, let me just show you quickly. So if you go back to the description here, over here, if you go to the API page for math, and if we go to the power method over here, you can see the return type is actually a double. And now, so that means over here, this method here, over here, returns a double value. And we are trying to assign this double value to an integer. So now there are two options for you as we cover in the elementary programming lecture. Either you can cast this to be an integer. That's one option, which means if you have any fractional part of the number, you're going to lose the fractional part. But in this case, you should be quite safe because b is guaranteed to be an integer, which we assume, and b squared must be an integer as well. And 4 is an integer, A is an integer, C is also an integer. So if you do all the calculation together, it should be an integer as well. So it should be safe to cast them into integer. Okay, that's option number 1. In this case, this option should be okay. On the other hand, let's say if you don't want to do any cast, then you can simply just do double. And let's say if somehow this number here, which we know will be an integer, happens to be 3, and discriminant is going to be 3.0, right? There's no fractional part, but it will be added just because we got a double type here. So you can go for both options, but you should really know why. In this case, both options work because we assume A, B, and C to be all integers. Okay, let me just go for option number 2. Yeah, so we don't have any cast. Okay, we got discriminant here. So now we're going to do some case distinction to see how many roots we have. So you would say if the discriminant is larger than 0, that means we have 2 roots. Else if the discriminant is equal to 0, that means we have just 1 root. Otherwise, we have discriminant less than 0. You may be wondering why we didn't write the following. Okay, so if I say less than 0, so why this is not necessary? Because, well, first of all, if you say if, else if, and else if, then that means you're missing an else. But now the problem is, what's really the implicit condition for the else part? Think about, for any number, it's either larger than 0, equal to 0, or less than 0. Is there really a fourth possibility for any number? Think about that. There's really no other possibility. So the else part here, if you just have if, else if, and else if, the else part basically will never be satisfied. We'll never actually reach the else part. So that is why it would be sufficient to simply say if larger than 0, else if equal to 0, or else, because the else part is guaranteed to be the discriminant is less than 0. Okay, just for this case, you should really know why having the third else if in this case is not really necessary, because that means the corresponding else part is never reachable, will never be satisfied. Okay, so now in the case of 2 roots, so we're going to calculate the the square roots of that number there. Okay, so now we're gonna do the following. So now if we have so remember we got the discriminants already, so we simply just have to calculate square root. So you say double, I'll just say square root of discriminant. It's a bit long name, but it's certainly informative. Okay, the square root of this discriminant is assigned to math.square root discriminants. Okay, and then we're going to do the following. We're now going to calculate x over there. So double. So what we can do is, because for the answer for the roots, actually for this one here, okay, let's do it here. Okay, because in this case here, in this case we're going to report 2 roots. In this case we're going to report just 1 root. And in this case we're going to report there's no root. Okay, so we can say in this case it's going to be double x1, because we're going to have 2 roots. It's going to be equal to minus b plus the square root of the discriminants and divide that by 2a. Okay, and on the other hand, okay, let me see what's wrong with that. 2 times a. Okay, And also x2 would be using the minus. So plus minus, okay? In this case here, we can say system.out.println. The equation has two real roots, and here they are. So you can simply print them out. System.out.println. The first one would be x1, and the second one would be x2. So this is the case where the discriminant is larger than 0. In the case where the discriminant is equal to 0, that means the square root of 0 would be 0. So that means double x is simply equal to minus b divided by 2 times a. Okay. And then we're going to say system.out.println. Let's report the only single real root for that. You would say the equation has one real root. And then we're going to say what it is. System.out.println x. Okay, finally, if the discriminant happens to be negative, then we'll simply say system.out.println. And we'll say the equation has no real roots. Okay, so now let's try this program for now. We are not done yet, but let's try. If I say 0, you'll simply say the equation is not quadratic. Okay, and then now we terminate. We are not repeating. So we did not. So now we are not asking the user, would you like to continue to calculate another quadratic function, because we haven't got a loop yet. Let's try another case. Relaunch the program. Let's say 2, 17, 32. Okay. Let's see, 2, 17, 32. It's not exactly what I wrote on the instructions. So let's see what's wrong here. We got, let's have a look. So this is b squared minus 4 times a times c. Okay, that's discriminants. And when it's larger than 0, we're going to have the square root of that. The square root of b squared minus 4ac. Okay, that's a square root. And then we say x1 is equal to minus b plus the square root of that divided by 2 times a. I suspect you may have to, I think the reason is because if you simply put this, okay, that's a good lesson here to learn. If you simply put this, because the divides operator and multiply operator, okay, let me put it here. The division operator, right, and multiplication operator have the same precedence. And for precedence, you should really refer to the elementary programming lecture. I'm not sure, maybe either elementary programming lecture or the selections lecture. You should really refer to the precedence. So they have the same precedence. So they will be evaluated from left to right. So for example, if you have, let's say, x divided by y multiply z, is as if you wrote x divided by y and then multiply z. Okay, so now we should really use parentheses to force the intended order of evaluation. For example, if you want to do division first, if you want to do division last, you can say x divided by y times z. Okay, I think that's what the problem was. Okay, so I'm going to put this here and put this here. Okay, that's quite a mistake I made, but I think fixing it also give you a lesson, so I think it's worth it. Okay, so now that's all we need to do. Let's test it again. Okay, 0, error. And now let's say 2, 17, and 32. Okay, that looks right. And then we have, so now we are done again. So now we can relaunch the program without repeating. Okay, and let's try 2, 16, and 32. So you got minus 4.0, just one root. Finally, if you got 2, 15, and 32, no real root. Okay, the program seems to work, except that after solving the roots for each quadratic, equation, the program simply just terminates without asking you, the user, if you would like to continue to calculate the roots of another quadratic equation. So that's the thing we would like to extend. So how do we extend our current program, further such that it is going to keep prompting the user for A, B, and C if the user wants to? Okay, we have learned this pattern for many times already, so hopefully that'll be quite straightforward for you to apply. So we're going to use a Boolean variable to say user wants to solve another equation. You can say initially that's true. As we mentioned in the lecture, in the lab session previously, the default value for Boolean variable will be false. So if you simply leave your declaration like this, the default value for user wants to solve another equation will just be false. So that will not be correct. So you want to say true explicitly. Okay. So you would say while the user wants to solve another equation, we're going to let them solve it. And then at the end of the while loop, we're going to ask the user, would you like to continue? The system.out dot print line. Would you like to continue? And either yes or no. In this case, we're going to read a string from the user. Integer string answer is assigned to input dot next line. And now, user wants to solve another equation is assigned to the truth of if answer dot equals y. Anything else will be considered as a no. Okay, that's how we update this Boolean variable here. So eventually, when the user do not want to solve a when the user does not want to solve any more quadratic equations, then this Boolean variable will be set to false. And then what's left is to cut and paste this single step here as the body of the while loop. And I think we're done. Let's give it a try. Okay, with the same test cases. 0, error, and now you can see the program does not terminate. You can see the button here is still enabled, which means the program is still running. Would you like to continue? Yes. So let's say 2, 17, and 32. Okay, would you like to continue? Yes. Let's say 2, 16, and 32. Okay, minus 4.0, that's good. And let's say yes, final one. Let's say 2, 15, and 32. Let's say no. And, I forgot to buy. Okay, let's try again. So after the whole while loop, so you can see over here, and while loop. So here you can say system.out dot buy. Let's give one more try. So let's say the last one. So 2, 15, and 32. Okay, no real root, no. And it would say buy. Okay, and now you can see the terminate button here is disabled, which means we have terminated already. Okay, it should be quite a simple exercise, but I think the main thing that we learned is about how we can use the relevant methods in the math class to calculate, to do the computation that correspond to some mathematical formula. That's what the main thing I want you to learn in this tutorial, in this lab exercise here. And also quite important to note is the division and multiplication. They have the same precedence, which means if you simply don't have any parentheses, the order of evaluation is going to be from left to right, which means we're going to evaluate this first before we do the multiplication. And in this case, over here, this is not what we want. We certainly want to do the multiplication first before we do the division. So that's why we need to use parentheses to force the intended evaluation order. Okay, that's the second thing you learned from this lab exercise here. Okay, so go through the solution carefully and then make sure you understand every point. Okay, stay watching.